The problem with GPUs that we've seen is that sparse stuff doesn't always translate well into GPUs because you have a lot of indirect addressing and things like that. But still, conceptually, I think it's possible. It's just it's going to be.
It's really hard. I looked at trying to do this in a GPU, and I kept running up against every clock cycle of the CLA. You end up with a different data structure in essence. I mean, these things map differently, and the GPU is built for video, which is basically
So,
it maps really easily.
we actually haven't done this, right? But we talked to a lot of people about it, and there's sort of a wild ass guess that says maybe the GPU might speed it up by a factor of 2 or 3 or something like that, but it's not going to give you a factor of 100, and it wasn't worth it because we can do other things to speed things up.
Yeah.
I think like a FPGA implementation or something where you can really create custom circuits that are really designed for the CLA could give massive speed up.
So here's something, I can talk about this because there's a group at IBM Alberton Labs who wants to build custom hardware for the CLA. And their first task they're taking is to implement it on a GPU. And the goal there is to actually just learn the issues about what are the problems, what are the difficulties, where are the bottlenecks, and it's not to do something commercial. So that's their current plan, and they're going to go through with that, and hopefully they'll share all that, the results from what they learned from that. But even there, they had to hire someone who's really, really specialty is GPUs. Apparently it's a specialty that some people know how to do. You need a lot of experience.
My problem was getting the data on and off the GPU every cycle, and then you just lose everything with the bandwidth going from the CPU to the GPU. So the only other way to do it would be to actually run the whole CLA in the GPU.
That's
in one
that's what you want.
That's the whole thing,
Yeah.
So
So even there, you have to really worry about sparse structures
and coordinating that GPU processor with all the others.
Yeah.
So we actually don't know, but the Superdome points out there's some reasons why it's just not going to speed up by a factor of 100. It'll be tricky and will be less than that.
How do you feel the process that you put together matches up against Prolog and that, because it's a deterministic process as well? Do you feel like Prolog follows a pattern that is brain-like in any way, or
Prolog is just a programming language, and it's doing first-order predicate calculus kind of stuff, which is, I guess it's logical reasoning, so the brain can do logical reasoning, but the process is nothing like what's going on in the cortex.
Coming to the same conclusions, and it's accurate or not, or you found that Prolog can be proven to be inaccurate sometimes.
I guess maybe I don't understand enough about
Well,
programming. I thought it was just
expert
programming.
systems.
Yeah.
It's a
basically
sequential language, whereas the CLA is a statistical-based kind of connection.
Well, Prolog, you're programming in the inference and so on.
Right.
Yeah.
Well, this is a learning system, right? It's a memory system, and you have to train it.
Well, but Prolog comes up with conclusions based on ties that aren't necessarily obvious.
Well, I guess there's a sort of there's somewhat of a schism in the world of machine intelligence and AI, perhaps. Many years ago when I started this, hardly anybody thought that studying brains was the way to build intelligent machines. I ran into lots of obstacles now. Now there's quite a few people who are interested in this. But it's really kind of two different worlds. Either you go for the traditional AI world where you say, okay, well, we can code up these rules, we can do all kinds of stuff, we use tools maybe like Prolog to do this, or you can just go, but I don't think you're going to, those two worlds aren't going to bridge together. I think they're really separate approaches. And it's not to say you can't do something very useful in Prolog. I probably can, but it's not a machine learning. I don't see it as a machine learning technique, and it's not a way of building something that learns about the world and from a sensory data stream. So I don't know how to take it further than that.
Okay, another question, sorry, was related to probabilistic approaches. Do you feel like the brain works in a probabilistic way sometimes, and whether you've thought about approaching it that way? I just wondered if that was part of your...
Well, if you followed Dementa for a long time, going back to when we first started the company, that we had another co-founder who's no longer with the company, and that was really his approach. He was sort of thinking about these as Bayesian belief type of belief propagation type of problems, and we've moved away from that. And but you could take the CLA and you could think about it if you wanted to in terms of probabilistic terms, but it wouldn't be a mathematically concise or I don't know what word I'm looking for. You know, we're not solving Bayes equations anywhere, but you can look at a sparse distributed representation is in some sense a probabilistic interpretation of that if you wanted to, but not in the strict mathematical sense.
Yeah, there probably is some way to construct a probabilistic theory around it. We haven't been able to. When we were doing the old way, we kept running up against various obstacles, and the theory didn't really help us. And it was, it's kind of interesting. The breakthroughs came in modeling the biology much more closely, and that's what led to a lot of the breakthroughs. And at some point, I think the theory will catch up. But there's a number of things that are just difficult to do with probabilistic theory and statistical theory.
Some people look at our work and they're very mathematically minded, and they'll say like, well, you know, what is the mathematical formalism for this? And there isn't one today, and it's not clear how hard, when we'll get there, whether you can get there. I mean, it's a complex system that we understand how it works. You can see why it's going to work, but it's not so easy to say, okay, here's the equations that describe exactly what it's doing. I mean, computers are like that too, right? We don't really have mathematical formalisms for code rewrite in CPUs. In the very beginning of the computing era, people were trying to do that. They were trying to figure out would computations finish, and there was the whole computability issue and algorithms discussions, and that dominated the very early, in the 40s, the early efforts in computing. But we moved away from that. We just, oh shit, they work. You know, let's just program them, you know.
Well, from a black box approach, it's hard to choose. Well, you want to throw hardware at it or software, and I know that you're not just hardware with NUPEC, but I wonder, in some cases, how to pick it over another.
Another what?
Well, another approach. So if I'm looking at Bayesian networks or something like that.
You'll have to come to that conclusion on your own. I mean, what we did is we had a pretty big list of requirements we were trying to solve, things we knew that we had to solve, the brain had to solve, and it just became impossible to figure out how to do that in other approaches. And I made a list of these things recently. So we had a set of constraints we were trying to solve, and we just weren't able to do it. Maybe someone else could. But then when we went back and looked at biology, it all came together beautifully. And from the perspective we have now, it's hard to imagine those two worlds coming together. That is, that you could solve these things in those other ways. I was trying to get that in my talk today, for example. I had one little moment where I talked about how this stuff is happening in a distributed fashion over the entire cortex. And because I was in a discussion a week ago with someone who's a neural network person. He said, oh, I can run sequences in neural networks. I can do these things. He says, I use a recurrent neural network for this type of stuff. And I was trying to I started going through the list of things. Well, it has to be online learning, it has to be variable order sequence memory, it has to be distributed. And when I got to distributed, he just said, oh, yeah, that's hard, because it's not a singular thing. It's not like one little thing that does something. It has to work across a sheet in the brain. And that's what's going on in V1 and V2.
Jeff, can we talk about